Hello everyone. Welcome to the lecture class for fluid mechanics. The course code of fluid mechanics is CE3301 as per Anna University. In this class, we'll be discussing a topic from Unit 1, fluid properties and fluid statistics. The topic is fluid properties. So before getting into the subject, it is important to know what is fluid mechanics. Okay. So we see what is mechanism and then we see what is fluid. Okay. So mechanism, if you see this mechanism is some application of force on a material, okay, or a study of the material when it is subjected to certain force, how it behave under an application of forces. Okay, so this material we are seeing about here is a fluid. Okay, so we know fluid, it can be either a water or it can be a gas also. Yeah. So in general, putting into a nutshell, fluid mechanics is a branch of physics which tells you about the properties of the fluid or the flowing material. Okay, when it is subjected to a force. So the application of fluid mechanics is widely varying. Okay, it is used in various disciplines like civil engineering. We use it in chemical, petroleum industries, aerospace industries, mechanical side, as well as biomedical and so on. So it is very important to know about the fluid mechanics for a civil engineer. Okay, so in this class, we will see about the properties of fluid. So in this, these are the content we are going to discuss in properties of fluid. We'll see the basic introduction. We'll see what is fluid, what is continuum, and some properties of fluid. So the basic introduction is, as I said, what is fluid mechanics? Okay, the proper definition is given here. So it is a science that basically deals with the action of force. The mechanism itself means that some force is acting on a material. Okay, so when the force is applied on a material, so the material here we are using fluid here. Okay, so the action of force on fluid when it is at rest as well as in motion. Okay, when the fluid is at rest and its motion. Okay, if the fluid is at rest, we call it as fluid statics. When the fluid is in motion, we call it as fluid dynamics. So in between fluid statistic and fluid dynamics, we have fluid kinematics. So difference from these two are, here is a fluid is in motion, but there is no external forces applied. So we call it as fluid kinematics. Is that clear? We have three different branches in fluid mechanics. We have fluid statistics, fluid kinematics, fluid dynamics. Is that clear? So statics mean it's state, it is at rest, the fluid is at rest. Dynamics mean it is in some motion. Okay. Kinematics mean fluid is in motion, but there's no some external pressure or force acting on it. We call it as fluid kinematics. Is that clear? Okay, we'll move on further. So this picture, this slides tells you in detail about the fluid static and fluid dynamics example. So the first picture is here a dam, a dam area or a catchment area, okay, where you can see this fluid, that is the liquid or the water is at rest. Okay, there is no motion you see here. Whereas in the second picture, when the same water from the catchment area is allowed to flow, okay, then the fluid is in motion. Okay, so from catchment area, the water is distributed to the nearby irrigation area or agricultural land. So this point we call it as fluid dynamics. So this is a very good example for both fluid statistic and fluid dynamics. So now we'll see what is fluid here. Okay, so fluid, if you consider a state of matter, we have three different of matter, right? We have solid, liquid, and gas, right? So the basic state of matter. So we classify into three. Okay, in fluid itself, we have two different forms. One is nothing but, we know fluid is nothing but liquid form. Gases also will form under fluid only. Okay. So in general, we simplify it, we call it as fluid. So fluid, it can be either water or a liquid, or it can be gas. It need not be always water here. Okay. It is liquid. The liquid, it can be oil, or it can be water, or any other. Okay. So how do you differ the state of matter? Okay. By the spacing between the molecules. Okay. By the spacing, how the molecules are packed inside. We classify it as either solid, either liquid, or the gas. Okay. So I'll show you the next picture how it is the molecules are being packed. Okay. So in first picture, you can see from the pointer is pointing on. So in solids, you can see molecules are very closely packed, whereas in liquid, it is partially closely packed, whereas gas, it is randomly placed. Okay. Based on the placing or the spacing of the molecule, we classify the state of matter. So what is the difference? Yeah. So if you allow the liquid to flow in, it takes the shape of the container itself and maintain a constant volume. Okay. Whereas gas tries to expand to fill the available volume. Okay. First picture is a solid, second is a liquid, and third is your gas. So this is a volume space. So it expands so that it can fit into the volume. So liquid are incompressible, gas can be compressible. So these are the different properties of fluid. We have mass density, specific weight, specific volume, specific gravity, viscosity, surface tension, vapor pressure, capillarity, and cavitation. So we'll discuss some of these properties in this class. Okay. So first one is mass density or density. The symbol denoted for density is rho. Okay. So in fluid mechanics, if you want to denote density, we denote it by a rho symbol. Okay. So density is nothing but your mass per volume. Okay. So mass per unit volume is called as a mass density. So mass is nothing but your weight of the material, and volume is the how much quantity can be occupied. Okay. So this is a general formula. So D is equal to, that is rho is equal to M divided by V. So if you see example of water density is 1000 kg per meter cube. So weight of the mass of unit is kg. Volume always is in meter cube. So unit will be kg per meter cube. Okay. So some example is solved here to determine the density of the material. Here is the density of helium at temperature. The quantity is given here and the mass is also given here. So we know the volume is given and next is mass is given. So we need to determine the density of helium gas. Okay, by using the formula, we'll be able to find the density of helium gas in kg per meter square. Is that clear? Next, we have specific weight or weight density. We denoted by the value is gamma. Okay, the formula for to find specific weight is the ratio between the weight of the fluid to its volume. Okay, weight divided by volume, we call it as specific weight. Okay, the unit here is Newton per meter square, meter cube, sorry. Next one is specific volume. Specific volume, it is defined as the volume of fluid that is occupying by a unit mass, or a volume per unit mass of fluid, we call it as specific volume. Okay, specific volume is equal to 1 by the rho. Rho is nothing but your density. It is the inverse of your density. Next, we have specific gravity. We denote it by symbol S. Okay, so very important, specific gravity. Okay, it is a ratio of specific weight of a given liquid to specific weight of a standard reference material. Okay, the standard reference material, we have it as water. So we have specific weight of a given liquid. Liquid can be a oil, or it can be a paste, or it can be a vegetable oil or petroleum, etc. Okay, so it is found with respect to a standard material. Next comes the viscosity. Okay, it tells you about the property of the fluid. So it offers some resistance of movement when over the other layer. Okay, it offers some resistance to the movement to one layer of the fluid over the other. Okay, so other word is termed as the resistance to deformation. Next, we have Newton law of viscosity. Newton law of viscosity, as it is giving a resistance between two layers, it creates a shear stress. Okay, shear stress in fluid is directly proportional to a rate of shear strain. Okay, so we have tau is equal to mu into du divided by dy. So tau is nothing but shear stress. Du divided by dy is equal to velocity gradient. Mu is equal to coefficient of viscosity. Next, we have kinematic viscosity. Viscosity in general is a offer resistance to deformation. It is defined as dynamic viscosity and the density of the fluid. Okay, so dynamic viscosity is nothing but your mu value. So okay, V is equal to mu divided by rho. So unit is given as meter square by second. So is that clear? So we have discussed in elaborate about some of the properties of fluid in this class. Thank you.